but it's, it's a challenge that we want to take, and we could make introduction that would take probably an hour. But I'm very curious, as each of you probably is, what we think, what we want to do, what we are doing. I want to be interrupted and have this kind of little by little know and understand each other's thoughts, because I think this is an experience that enriches everybody. Maybe I will ask who is like working on a startup or having a startup idea in mind. I'm one of those.
In fact, then we could do that. The other thing is we could just, it won't take that long. Let's just go around the room and just request everyone to just introduce themselves. Shall we start with you?
Sure. Hi everyone, I'm Mark Rose. I'm a product guy, recently unemployed, so looking to start my next startup. So maybe in this space actually. I did a lot of work in contextual computing on mobile phones most recently, and so looking for my next thing.
Yeah.
I'm Jill, and I'm working on a startup doing cognitive computing in Psyche. I talked to you last time.
I'm Ed Zink, and I'm starting a new job in a couple weeks with Volkswagen.
On the connected car.
I don't know what it's going to be yet. We have to propose our own ideas. I'm David, I'm an electrical engineer, and I'm interested in computing.
Randy Moore. I had some experience in artificial recognition system in Vienna Technical University, and I had some experience in artificial intelligence. My background is electrical engineering.
My name is Bert Nieves. I'm working now and security software, and my background is software architecture and analytics.
Nice.
My name is Pete DeMarco, and I've done a lot of embedded systems software. But in college, I studied a lot of AI stuff, especially the stochastic AI techniques like genetic algorithms.
My name is McLean, working with Jill. I have background in cognitive science, and I spent the last couple of years looking at behavior change tools and interventions and how to make them more effective.
Yo, I'm a developer. I'm Samyak, and I'm more interested in the cognitive science. So that's why.
I am Mushfiq. I just finished my PhD in electrical engineering, looking for jobs right now. During my research work, I got really interested in cognitive computing, and especially that's why I joined this group.
I'm Irene Weissman. I work for a large company as an enterprise Java engineer, and in my spare time, I take interest in artificial intelligence, and I'm thinking about a product that I could develop, and so I'm just looking in what exactly directions to go, or maybe in all of them.
My name is Gloria. I am building an adaptive, personalized language learning system for young children. And I have a computer science background, so I'm hoping to learn more. I'm actually I'm trying to figure out how that data model looked like as it relates to cognitive computing, contextual text processing, etc.
I'm Katie Gutierrez. I work in usability testing, UX, and I have a background in interactive design.
So my name is Wen Pailu, and I work in the networking area, and right now I'm focused on the product management. So I'd like to learn what it is and how that can be applied to the networking, especially we talk about software-defined network.
My name is Ed Katz. I have a background in traditional AI. I have a background in computational intelligence, primarily fuzzy logic. I have a background in robotics, both in manufacturing and in research. I am steeped in agile software development, and I'm between jobs. One thing that I want to do, and I keep coming here, is understand I run into terms like cognitive networks, cognitive radio, and of course cognitive computing. And I'm wondering, is cognitive being overused as a term, or is there some common thread among all of these?
You're not the only one.
Hi. Hi, my name is Diego Pacheco. I'm Brazilian. I'm working here with Thomson Reuters, kind of a Facebook for science. My background is software architecture, analytics, big data, and also I'm an agile coach, so I'm pretty much interested in people and analytics and big data itself.
My name is Benjamin. I run a two-man software development shop. We build prototypes and proof of concepts for clients. So typically they're websites and mobile apps, and we'll build the initial first version of that website or mobile app for our clients. And yeah, that's pretty much it.
I'm Ronald. I run a tech startup specializing in natural language processing, which requires lots of cognitive computing, and mostly I'm seeing. So I'm very interested in learning more about that.
I'm Alan. I'm just interested.
What? Nice to meet you.
I'm interested.
Okay. So maybe I can answer some of your questions. I'm definitely not an artificial intelligence person, so I may disappoint people. I see that quite a few people have this background. I will talk a little bit about me. I'm an electrical engineer also. I got bored and I said, I'll do also be a bachelor in mathematics, but then I was in the same class with people whom I knew from the university, and at a certain moment they were talking about things that I couldn't understand, and I said, stop, I cannot do that. So fortunately the computers were coming in, computer network actually. So I moved from telecom to software engineering and computer networks, and I did a master in computer science and then a PhD in computer science. And that moved me from the Eastern Europe to the Western Europe, and I started to work on building the internet backbone, the major internet backbone in France, which was called Renater. That opened my eyes to new ways of doing real-time communication. So I got involved with IETF, and then after finishing the PhD, I moved to US, and I worked with a few companies. The first one was Oracle, which I really enjoyed. It was like the Ivy League School of Software Engineering at that time. Then I've got more interested in smaller companies, like a startup, Wiley, that was acquired by CA. So I got more into enterprise IT, and then from enterprise IT into software delivery platforms for telecom. So I moved back to my telecom background. What I'm doing right now, after actually spending 2 + 3 years working on a contract with a Chinese company, Huawei, also on software and then very related to software-defined network right now. What I'm doing since May, doing what I dreamed, which is build a small company, a nice software product that is light and is helpful. So I co-founded Zipabyte with one ex-colleague from Oracle and also Huawei, who is an expert in BI systems. And Zipabyte is an engine that organizes data for analytics so that it is extremely fast and also light, and it can disrupt quite a bit of the data warehouse, data lakes, data, all kind of swamps that are building up right now. And what I do in spare time, I think about the history of computer science, and the fact that I moved very fast and probably I missed a lot. And the cognitive computing group was an opportunity to review some of the projects that I took over, I've been through, and then I just dropped and moved on. Like you will see, it will be more of a sharing experience rather than, you know, deep technology about a certain product. I collect hand-painted plates, so everywhere I went, I had quite a few roles which were very customer-focused, and so I had to go to many places around the world. And each country I go to, I find something that is a plate that is hand-painted, and I have probably 40 of them for P1. So, just like you, Ed, said, I use the word cognitive even during my PhD. And now we hear it associated with cognitive neuroscience, cognitive behavioral therapy, cognitive computing. So a lot of cognitive. So over the years I've got interested in what you see in that hexagon, those domains of disciplines. However, I never put them together. And just preparing this presentation, I said, well, what is cognition? And then because cognition and cognitive computing and cognitive systems are very new, I wonder what is the science behind. So cognitive science. And doing some research, I found a paper that answered my question. So it was an effort that was enacted by university professor, researchers, experts, who realized that somebody's problem could be easier solved if somebody else's in another discipline problem were solved. So yeah, it was in a way influenced by the computer, but at the same time it was a realization that just keeping separated those disciplines, they will advance slower. So they put together this proposal to the Sloan Foundation about an interdisciplinary effort where 6 domains would be associated and would work together. So experts in those 6 domains will come together and will try to not solve only their own problems, but each other problems. Because there was no other way, no other better way. And they aimed at this universal science, and I think in history we make this mistake again and again. That there is a universal something, something that would solve our problems. The report about this necessity was accepted by Sloan Foundation. The report itself was very difficult actually to be constructed, and explain the need. Because why? Because each expert was very good in their domain, but very few would agree to converge. So after all, only 3 of these experts signed that report. And Sloan Foundation accepted it and funded it. And actually Cornell got a part of it, and there is a prominent professor of neuroscience that participated from the beginning and wrote the report. and then some people from Carnegie Mellon also were quite active. However, I lost the contact, so Sloan Foundation didn't follow many years after. People got the awareness, but there wasn't a very cohesive effort. In particularly that time in between 1980 and 2000, it was like silence. There is very little about it. And it is really the time when software engineering, took off, enterprise IT took off, internet took off. So all these areas that are issued from computer science have, really flourished. But the others, which are more humanities, somehow couldn't keep up. So that is a chasm that I don't know, I couldn't find, and I would be very interested to know if somebody remembers what happened between, in that 20 years lapse. However, we look now at cognitive computing because this is what we are trying to define in this meetup. And I found IBM's path, which is very, very work, it's not just marketing, so it has some knowledge and goal quite well articulated inside, which is basically to find a new technology for chips. And I associate this with a paper that I read from the National Research Academy, which talks about the limitations, the hard limitation actually in the semiconductor technology today. So it's not really the density of transistors like the Moore's law. It's more about the power that is dissipated as this density grows, which was supposed, then I think it's called the Deming law, which was supposed to be constant, but what is observed, and now I'm an electronics engineer, in fact, specialty, and although I did more software and computer and IT, but my husband still designed circuits, and I know, like firsthand that this is the reality. The heating of the semiconductor makes the material behave differently from models. And when we know that so many companies bet their, let's say, cost reduction on the Moore's law, basically they didn't upgrade the equipment because they knew in 2 years, it would be much faster for the money. It becomes a problem. And it becomes a problem also because a lot of software has been written without really thinking about efficiency, and that contributes to it. So IBM, what I mean is IBM has a very real goal set in mind. My surprise is that the solution is cracking the human brain. And it's not really like a big surprise, it makes some sense, the levels, like when we look at the deep learning, the way it's done, it's layered, it is tailored for parallel processing, and one way to really delay the moment when the chip technology cannot carry so much computing power demand is basically to review the way we write software and do more parallelization and also better algorithms and maybe better distribution of where the CPU is needed versus where the communication has to take place. But yeah, I was intrigued, surprised. It is a very realistic goal. It just never hit me that thinking, or actually acting the way our neurons act could be a solution for the semiconductor technology problem. So although IBM calls it the path to cognitive computing, I think the meaning behind is very different from what we would expect. So it's not really like artificial intelligence is, by the way, we are still going to compute. However, those chips will be built the way the human cognitive system, or will be built to work the way the human cognitive system works. That's what I took from that. So that's why I am intrigued. I don't know exactly which way we are on, but something is happening, as it always is. So then I took piece by piece, cognition and cognitive computing and cognitive computing systems, and in trying to figure out, can we come up with a definition? I think this group also tries to achieve this, what is a definition? What is cognitive computing related to the definition of cognition? And what are cognitive computing systems? And these are, definitions and statements that I found on public sources, Wikipedia, and then IBM, because I needed one. So then I looked at them and I started to ask questions. So if cognition is defined as the set of all mental abilities and then the processes that these mental abilities get involved in, what I noticed in this definition of cognition is that the notion of identity, like the observer perspective, is left behind. And that doesn't sound quite well, or quite right actually, because, cognition means autonomy and then interaction, learning, so it always expresses a point of view. And yes, I understand the need to put the man and the machine in the same whole, in the same system. But I'm not very sure that we need to lose the notion of identity in doing this. And as we move towards everything digital, we see that there is this tendency to basically efface identity. And I'm still, fighting for a digital identity. Like every trace that I leave behind, in fact, I made that trace, so it should be possible to recoup it. It should be possible to ask for what I have done with, going everywhere on the web and searching for this definitions, let's say. I don't know to whom exactly to ask that. However, if there was this notion of identity, then it would be easier to recoup my traces, because we need to respect each other's identity. So yeah, it struck me that the notion of identity was left, outside the definition of cognition. And then when we think about cognitive computing, that's an adaptation. So it, even from the perspective of IBM Pathway, we see joining a technology, nanotechnology, and we see the neuroscience, and then the supercomputing. So here what bothers me is the other, like, humanities disciplines which are left behind. So again, I have a question here, and then most of my presentation actually tends to be more in the humanities. So it's not that I want to save my presentation, but I do think that thinking from you know, the philosophical perspective, psychological perspective, even anthropological perspective, because look here, we are in this country, we speak English with, you know, more or less of an accent. Probably we have been trained in a very Western culture. However, across culture, this does not hold. So there are concepts that are not at all the same, even if they are, you know, drawn or the words are the same. So in a world that has a common denominator, the digit, the bit, and it's a digital world, I think we should not leave behind the cultural aspect and the beliefs and so on, which are all part of humanities. And then the cognitive computing systems, that's, you know, a system has a purpose. And I looked at, you know, how the purpose of cognitive computing system is designed, is expressed. And it really sounded to me like the social technical systems, you know, maybe 10 years ago when we put, you know, people and machines, the whole IT, enterprise IT type of deal, where people and processes were like working in a kind of a fluent continuum and so on. So I do think we have some work to do in you know, pondering over the current definitions and the questions, and I'm pretty sure each person in this room has their own questions about these definitions. So I went a little bit further into, let's say, the alternatives of the Western, not the Western, the very advanced technology-oriented computer science. So basically, I did a drill into the beginnings of the cybernetics, because I do believe that chasm between the 80s and 2000 has something to do with that. And there was a kind of a, you know, elite class of cyberneticians coming from UK and with some ramifications in the Latin America, who were taking a completely different view on cognitive systems and on the term system in general. And they said, you know, in fact, if we look at the evolution of cognitive sciences, at that time, so 70s, 80s, it was all about using software to solve problems and, you know, expressing problems in a computer language and using the computer to automate or solve faster. Then they said, you know, there is this era of emergence, which I can associate today with what I see in the way deep learning research happens, where we train from bottom up, and we hope to be able to identify not only objects but concepts. So basically, create abstractions, make the computer create abstract concepts, and with this solve complex problems like the salesman problem, or like the problem of the high-speed training in Japan, which I think some, not ants, but even simpler form of being was able to draw the optimal path through the shapes of the land in quite similar way that the architects did. So these kind of things I think happen now out, or will happen out of the deep learning. And so then the question is about the future. So what IBM dreams about and what we are talking about when we mix machines and people in the same context is this inaction. Some futurists talk about the synthetic neocortex. Again, the IBM works a lot on the Watson. Would it be a personal Watson or would it be a synthetic neocortex? And that is the question for the future of cognitive.
What's the difference?
Well, so synthetic neocortex, it's still maybe my identity, while a personal Watson, it's more of an object. For me, that would be the difference. A personal Watson I associated with a wearable, and I'm not very sure that the neocortex is a wearable. This is a wearable. This is a wearable, and I can.
So it's basically size?
And not
one is on your wrist and the other one's in a big air-conditioned room?
And I would say this one I can put away and turn off. I don't know if
Well, your
the other
personal
one.
Watson can connect to your synthetic cortex.
Absolutely, everything can connect to everything today. So yeah, this is the foray that I've done on the cognitive computing and then cognitive sciences. As I mentioned, I am more attuned to introducing the humanities into this environment. And that comes from some personal experiences, mostly related to professional life. And then, easy to identify in the day-to-day life. The fact that we are a poor processor and we have limited capabilities, so that has my intrigue, my intrigue with copying the human brain in order to reinvent how the processor should work. We are limited because of our structural, biology, and also it is observable. This is human behavior. We have a so-called fast system and a so-called slow system, in the sense that most of the time we react quickly because the fast system takes over, and then it would be better many times to wait and then so that the slow system can catch up. And then we act and reason on conceptual representations of the world that we form during the years, and they are very dependent on where we are born, the education that we have received, the language that we speak, and this is why linguistics linguistics and the language that we hear can influence the way we reason on what we hear. So these are the conceptual differences that if we do not think about or experience, then it's easy to, forget about them in cognitive computing. So where are these things packed together? They are in what is called the tacit knowledge, the one that is very difficult to express even through language. A lot of work is done and is done because of economic reason on the explicit knowledge, and I think this is really the core of investment in cognitive computing, because it can be exploited. Yes.
So it's, you say up there, it's hard to articulate in language.
Yes.
Can you say a little bit why that's the case?
Because at least two aspects of this. Language is the way we learn. So we learn in the native language, and languages are different. So
Do you need a language to learn?
that's the problem. There isn't really a universal language. There was an effort to build one. However, it failed. A language is also a product of the mind, and it's very, very much related to the creative human being put in certain circumstances. And what is noted is that the number of languages on Earth diminishes. That's just worrying that the creativity goes down. But yeah, it is very hard to translate the meaning between languages that have nothing to do with each other. For me,
I was just going to ask, wouldn't tacit knowledge be knowledge that's learned at the subconscious level? So squirrels learn, but they have no language. And so there's a lot of things that we learn in terms of motor, sensory integration,
Yes.
things like that, that we don't know how to express because we're not even sure at a conscious level what's going on in our bodies 100%.
that's subconscious. Why tacit knowledge is important is because this is where creativity sits, and this is where decision to act sits.
Can I take a little stab at this one too, or just another place? I often, from the education, science, math education theory, it kind of is a concept of reflection, and the idea that if you think about working on hard physics problems, often you invent math to find the articulate the solution, but the precursor to that is lots of sitting with cognitive dissonance between something you're visualizing. Let's say, like in Einstein's example, writing about the electron, he's visualizing some paradox, and how can that be true? I can't wrap my head around it. So you're wrapping your head around it in this wordless space, and then when you want to articulate it into communicate what you think is the truth, or have a set of tools to prove or to you need to construct often that language, like or math to do it. So I think there's kind of this idea that you start out with enough of a symbolic space that you can have a juxtaposition, so there's dissonance, and so that invites the reflection, and then you may be able to perceptually see things you can't communicate yet until you find the next layer of communication.
Yeah, it is like this. It is about concepts that we form in our mind, and they may be common. However, there are slight misalignments, and you only realize that when you live in a certain culture, and then when you are taken out and then put in a different culture. Because it's exactly like with math. Math is the same because it's abstract. However, when you get to the implementation, you will see even people from the same culture, same education, they will implement with slight differences. And it is very interesting what language does to our brain, because it forms it to think in a certain way, it to behave in a certain way. So, yeah, it's not really like in programming language. When you are in a domain specialized, then you may say that, yeah, we have a common language, but that still doesn't think they think the same way. But you cannot expect everybody to program, to learn, a certain programming language. So, and then we don't have other means. Yes, I believe a lot in visualization. However, I can draw something that you will still ask me, what is that? So then we get into language again. And yeah, this is one of those difficult problems that cognitive computing should tackle at least.
Would you say that tacit knowledge requires embodiment? And that you have to have a physical body, either as a robot or as a creature, a squirrel or maybe?
Yeah. So here we get into the philosophical, discussion, which
when you have a body as opposed to a disembodied AI floating around in a virtual machine, you actually interact with the environment at a very low level, and you get a lot of very pre-symbolic data flying in.
You remember I said two things about tacit knowledge: creativity and decision. So, show me a body that has these two properties.
Well, you need a body for anything, so everything has to be physical, right? So, but you can kind of think of tacit knowledge as a right brain activity. It's kind of like fuzzy logic, and language is on the left brain. You use binary logic, basically, or something like that. You can still make decisions on your left brain, too, but usually you make the decisions on your right brain by just weighing things fuzzily.
One piece of evidence that I think might be interesting
philosophically
is affect. Just the idea of affect and how much that. This is just totally sci-fi. Maybe probably other people know more about this, but just reading articles that maybe we aren't even possible. Maybe it's not even possible for us to parse our visual field without an emotional coupling, a weighting. There's a weight function, and that is tied to us, that because we are tied to an affective feedback system. So our preferences, our emotional preferences,
sensory perception.
That our emotional preferences are completely tied to our perceptions, which is tied to a weighting function of our, feedback of negative and positive. So that there would kind of be, like in the AI system, without any kind of affective feedback, it wouldn't have the weightings to actually do perception. It would just be flat.
Yes, in a way, I would say, let's leave the perceptual sensorial level and move one level up. So as soon as we get into fetching a memory that is maybe solicited by the perception, and then with the memory comes some models, some mental models. That is tacit knowledge. That's where we start engaging knowledge. In fact, the cognitive abilities of the brain. So at that level, I think the tacit knowledge is important. Because, yes, you see, it takes the experience, so definitely, you know, perceptual, sensorial is involved there. But then it does something with it. It solicits something internally from the memory. It starts to conceptualize and then express. And that is where we get out and we begin to have arguments because we are not quite aligned, for example. As long as everybody agrees on a concept and the way we draw it and the way we name it and what the meaning that we put behind, then that becomes explicit knowledge. However, my interest is more on the tacit knowledge because I think it really burns a lot of our resources. And the more we look at it and we help ourselves overcome, you know, these problems of expressing, conceptualizing, working with many mental models, working through our biases. Biases are in there also. I think better will be the cognitive computing contribution to the humanity. So because it's a difficult topic, I prefer to go through some of the experiences that I think are very related to this and just share them with you, knowing that I am not an expert in cognitive computing or in cognitive sciences or in artificial intelligence. And then using the group to interpret or to draw some conclusion or even, you know, pick up some work out of that. I put them in 3 categories, but today I will only cover the first 2 because the third is really very interesting, but will take another session to go through it. So the first encounter with cognitive systems and cognitive computing, and actually there wasn't any like cognitive computing at that time because it's 20 years ago, but the human cognition involvement in building the real-time communication and collaboration, I really hit that part during my PhD research. And I will share with you what I've done and some results, and you'll see. I hope I can catch, you know, some example for the tacit knowledge in there. And then also the life as a software engineer and you know, working in software-oriented companies and working a lot in enterprise IT, telco IT projects. That also revealed a lot of the influence that the tacit knowledge has and how helpless we are, particularly from this computer support in overcoming the weaknesses we talked about. So in my PhD research topic was group communication in a completely mediated by computer environment. And it was the 90-something, the times of collaborative work supported by computers, which was particularly teletraining, professional training in enterprises. Didn't have much to do with communication. It was more of, the classes that in big companies you still have to take online. So something like that, centralized server and then people on computers taking those classes. And at the same time, internet was coming to Europe, and IETF was really a very good supporting group for the new technologies. And there were some very bright people, many of them around here in Silicon Valley at LBL in Berkeley, who, and then some at Stanford, who said, you know, let's do more than just packet IP communication. Let's do real-time video audio over IP and over very unreliable networks at that time. So it was quite innovative, core innovation for the time. So looking at what existed and in this kind of teletraining and the technologies that were possible, I tried to mix them. And I tried to change the way we look at group communication and actually collaboration towards a common purpose, accomplishing the task, whether that task is learning or producing something together. Immerse the group in the mediatic environment instead of having the computer as a communication tool. It was really the person and the computers as a system where people were working together like in telepresence, but without really working on the communication here and then on what they needed to work there and being disturbed. So I said, you know, I will try to build an environment that each person can tailor the way they want, the way they feel naturally for, you know, the interaction that they have to do or feel they want to do with the group, knowing that each person would act in isolation like we do when we work from an office, a cubicle, or at home with the computer in front of us. And then everybody else elsewhere, we don't know where. I just wanted the group to feel together and work together and accomplish a task. So I had to build a prototype. I was happy that there were a lot of applications already made available, and that the design of these applications, so the architecture behind both the transport and the application itself, was such that they were very independent, which allowed each person in the group to choose whatever they wanted to work and like and put it wherever they wanted. That I will make a comparison with, you know, something like WebEx today, where you cannot really put the whiteboard somewhere and the video somewhere and on your desktop because you need space. It's there and this is it, and you have to use it the way it is. My goal was, in fact, to observe how people would work with a system that is very flexible. Would they end up with an interface like WebEx or something else? And I will show you how they will end up. At the same time, it had to be something that allows the group to do the work and also measurable in the sense that, well, if it's nice to use, but people cannot do their work on it, which, you know, two of the challenges were want to do a lab, like an experiment, and the other one was really to build a design and simulate the manufacturing of a piece of equipment in a car in this kind of environment. So I had also to do the kind of comparison between the mediatic and the normal way these people would work, like in a class, in a lab, or in a work environment, and compare the results. So 20 years ago, how should I put it? No surprise or big surprise. It was the same concept for giving a lecture. So as the webinar today, the part that I had to do, like the experiment, was what is the comprehension and, the lecture by itself in a mediatic environment. How does it compare in terms of objective results, learning, with what's happening in the normal class? And I've got 3 types of population. One, the Lucia one, which is in the main group of observation in the mediatic environment. I've got this similar group, not the same. So classes of students were split in half in normal class, half in mediatic environment. And then I've got some students who were younger. So these guys were in graduate school. The yellow ones are younger, in undergraduate, who were just curious about the technology and they wanted to participate in the experiment. And then the professor had some points of verification regarding the memorization and then the understanding of concepts. And here we see that in terms of memorization, the physical one, the physical presence, ends up being better than the mediatic one, while the comprehension, the difference is not that much. So that was the lecture. Go ahead.
What was the horizontal axis on this?
These are some concepts, some points to test. So because these are average, and let me see, it's the level, or if this is percentage, then this is the level. So how many in the group, the percentage, and the level of comprehension, and how much of the concept they remembered. And we thought a lot about the test, and yeah, it's a long time ago, but I remember these were like the standard way in pedagogy to do evaluation. So I had to go through the canonics of evaluation in pedagogy for, like, when you give a lecture as a professor, how would you test your students, and memory and comprehension were the two. And then the professor would say, well, it's not a zero, it's a no comprehension or all comprehension, so there are levels of comprehension. So
was your sample size big enough to make any valid,
So I had around 60 students, and we ran them in so 30 physical, 30 mediatic, and then by groups of 10. It was a 1 semester deal, so
you can make a valid conclusion from that. I don't know.
it was more for experimentation than for, you know, really validation. But, you know, some things they show up, some things that you cannot imagine or really put a finger on. They show up in this kind of experimentation. I think more interesting is the really high interaction part of the experiment. And for this, I use those tools that will allow people to basically craft their own desktop, but at the same time, be able to write together what they needed to do. They needed to design an object, a mechanical object, based on the, you know, some conditions. It was mechanical engineering. Then write a program and then submit it to a simulator and run the simulation. So it was really a project that they needed to execute together while in this environment. And this is just a snapshot of one desktop, and each desktop looked quite different. And here it's not only about the results, which somehow, surprisingly, somehow maybe not, they were better in the mediatic and faster. Yeah, they didn't have time to talk that much, to like chit chat. They had to do the work. There wasn't that proximity that will, let's say, instigate chatting. And then for this part, I also built a kind of usability test, like questions that will reveal the usability of this kind of environment, and did some analytics, like an analysis in what are the main factors, the grouping, the clustering. There were like 20, 25 questions in the questionnaire. And there were, 4 clusters identified. One was more about would you accept this kind of environment to work in? The other one was, how difficult was the work to be done? And the other one was, how about your own effort to put, like human, physical, psychological effort? And the fourth one is based on more on technology. Was it responsive enough? And again, the results weren't that bad, actually. Actually, there were, some of them were quite good. So yeah, it helped a lot. Like we got into an European project, and we got a lot of money for the lab for a few years. But anyway, I look back. So the point is more about what is happening today in cognitive computing. So I look back at the tools that we have to do this kind of real-time collaborative work, creative work particularly. And basically, I don't see this kind of flexibility anywhere. The possibility to write a document together at the same, like really real time, or do the type of project that was done. Not like at the internet scale. We're still in the Skype, WebEx kind of things. And then I did a parallel because I was listening and reading a lot of Professor Sapolsky's classes at Stanford. And at a certain moment he talks about the way we remember things and how chaotic we are in searching for a name or for a day or for something. And that was quite similar with the way I saw the students working with this kind of tool. It seemed chaotic, but for them it seemed very natural, that they put video here and then they were drawing here and they were very caught into this collaboration in real time and the reward of seeing that the program works and that the project was accomplished. And again, I don't see this kind of flexibility. Or the technology was there, was viable. But so far, no. What I have noticed is that, that kind of technology picks up now. It's more about a certain way to do the transport layer in order to support this kind of flexibility application layer. And I assume, it's an assumption, that it was more of a telco economics kind of blockage.
So would you consider this an example of cognitive networks? Computer networking context?
Actually, it was much simpler than that. It was more application adaptation to the network. What we still try to do in network is network adaptation to application requirements. At that time, because only telcos, really owned the network, and the network was extremely diverse in terms of bandwidth and very small bandwidth. There was a lot of work done in making the application quite autonomous. So it's more like the application has the cognition and takes some precautions and has some built-in intelligence to adapt to the situation. Like the concept of elastic buffer was put in place at that time, and that helped a lot with the jitter in the network, because that is really bad for the audio and the video. A lot of simplification in the layers, from the OP7 layers, and then even from the TCP, actually the UDP was used instead of, because of the window problem and retransmissions and so on. So the technology was working when the bandwidth was 125 kilobits per second. Why wouldn't it work? Wouldn't it be largely used today? Do you have the answer?
I don't have an answer, I do have questions. But I'm just thinking back, maybe you can speak this a little bit, that portals were all the rage about, about 10 years ago or something, when you customized your portal and you wanted to put this thing here and that thing there. That was we all had to have in our enterprise solutions, some home base of a portal, I want to see these reports and this thing and this is how I want to arrange it.
Yeah.
I don't know what, I just thought,
But move them in real time. But it's like tiles, like we do now with tiles.
Do we still, is that still I have a little out of it, I guess, but with the advent of apps, is that just dropped away, or there's still solutions where we do that I'm missing? Do we still have this really concept and design?
The portal?
Yeah, is the portal dead? I don't know.
It's not dead.
I'm kind of naive.
Yes, but the mobile apps.
Don't really allow for that, right? You're kind of getting more into prepackaged.
You still see it in enterprises.
You still see it in enterprise, but the user direct consumer
It
experience.
doesn't have that fluidity.
Right.
You see, this desktop had fluidity in the sense that I could, push away the video, bring up the whiteboard, depending on what I was working on at that time. And basically organizing and reorganizing my workspace so that I am productive, not I am following us. Yeah. And it's not only me. I was in a group, I was talking in real time. If one of my colleagues was asking me, look at that, I was quickly looking at that, not, looking at what was the preset. So,
one consumer example might be Twitter. Right? So you used to have portals that really like Twitter is curating topics that you kind of want in your tiles, right? I mean, that's really what Twitter is, right? It's just
I don't know.
stream.
That's why I'm being really naive because I'm not that much of a consumer technology.
Well, you curate who you follow and the content that you see, but it's just real time. It's different because there's a
I make a
but
connection.
you don't get to like set something. You don't get to like figure out your optimal way you want to interact with the information anymore.
You can by who you follow, right?
So this is what, in fact, I expect from the word cognitive and, coupled with computing. It really adapts to my brain, which is engaged in some activity. Could it be entertainment? Could it be real work? But it has to adapt, and in terms of responsiveness, and in terms of preferences, like or maybe even fit to my way of working without impeding on your way of working, which might be different, although we are working exactly in the same place, somewhere in the middle there. We are modifying the same object. And this aspect of work, it's probably considered messy, it's non-conformant and left out, but it impedes on people's creativity and even efficiency because, maybe the results were not statistically, let's say, valid because there weren't enough students. However, these guys were working faster this way, and they found their way around very fast.
Yeah, I find, I get frustrated when I have to reboot my computer, because I feel like my computer environment, once I get set up by multiple screens, it's Linux, I don't really kind of worry about anything. Of all the things, this is how I'm thinking right now.
Right. And then you need to reboot, and
this way you open Windows, or you're kind of like, this is the order I want to read stuff, and maybe I'm going to have a different, I've got my own system for managing my workspace, and there's nothing that supports me in that, and I have to restart the computer
and
to reset
think
the
now at larger scale where we work together, like all of us, and each of us has their own order, but we accomplish something in common. That is, I don't see it anywhere. And I think could be a
So just like taxonomy has the limitation, and people came up with paucity where you take things, like YouTube has a tagging system and they call it paucity. So I'm taking my own way, somebody else is taking the same objects on their own way basically. So I might be saying this video is awesome and somebody might be saying it excellent, but still a common system emerges, and you can derive something like, okay, this video must be of certain rating because somebody has tagged it awesome or somebody has tagged it excellent. So I'm not I'm not impeding on your tagging system. I'm not allowing you to, I'm not disallowing you to have certain words only used for that object, describing this object. So that's
you jump ahead, because that's my next, that's the next thing, which I need to run through.
You just wanted
Yes, because it's 8:30.
Heads up on time,
Yes.
It's 8:30.
It seems to me like a lot of times we are trying to mimic what is in like face-to-face environment. Right? Everything you do in a credit program is trying to mimic what is in this environment. So when you're face-to-face, you have a whiteboard, you have sticker, you have all this. But when it comes to this telepresent, I think it's not the area. One thing is the limitation of either technology or the space. Just like a computer, right? You like to have a multiple screen, and you have to pass the thing around. Just like you want to work You like to have a big table, so you can have this here, this here, this here, this here, and you can look at the same time. So I think a lot of times it's not the behavior, it's more like the limitation of the technology or limitation of something. And then that's one aspect of it. Of course, I think we need to study it from a human behavior.
Yeah.
What do they think about using this technology, using this kind of, is that by using this they change their behavior, or they still stay in the same behavior? If you stay in the same behavior, how is going to adapt to what they need?
So you are absolutely right in addressing the topic from these two sides. The discipline where we discuss this is not computer science. It's somewhere in the humanities. So they don't meet. What I tried to do, the first thought there was, people spend too much on discussing the technology for telepresence, and they forget that these people, in fact, they are not in telepresence for the sake of telepresence. They are trying to do something together, and then they will discover what they need as they are doing it. But there was no tool to allow them, because it was a all or nothing. I mean, picture tell or nothing. So I said, let's give like piece by piece and let them use each piece as they need, which is more of the concept of communication of living organisms through interactions, not through media or channels. And again, we get into philosophy. I don't know if anthropology will play into this, but definitely computer science doesn't deal with that. It deals with technology. Communication, do we have enough bandwidth? Do we have enough CPU? So cognitive computing, should take a stab at this. Now getting to the next point. It's more about software engineering, and I don't want to bother you with, quotes from the past, including one that says we will not need computer programmers because they will all be gone in 1985. That's right. So and it wasn't really, I mean, Herbert Simon is cited many times for many good things, he said. Software is important for the economics of mass production, but it's more of a booby trap, I would say. Why it is good? Because it is perceived to be easy to develop and make, because it's just writing. That's how it is perceived. And it is easy to change because it's, just writing, intangible. And the change process is also easy because there aren't many, I would say, offices, plants, supply chain to, get into in order to change the process. So, that is great. So let's try to do more software and less hardware. However, one of the first lessons learned from experience was that the linearity in manufacturing, where you add more people, you have, more products, so it's kind of linear, doesn't hold in software projects. You add more people to a project, the project takes longer. And sometimes, and actually mathematically, would be exponentially longer. Why? Because people have to communicate their thinking, their concepts, the design. And particularly at that time, there wasn't anything to support that. And then the next step was, well, you know, we have to do something about it. So influenced by standards, the universal standards. Here comes the UMLization of software engineering. Just it is done on paper, and it is basically a wrong usage of computer to produce more schematics. And it goes against some laws of living systems, like systems that survive, maintain themselves. Instead of attenuating the variety, it creates more variety. So now we have more documents to fill in, more Excel spreadsheet, more designs, schematics, and even the project manager, we have to fill in the resources and so on. So really what is happening is that the bubble roll, and we get into this massive software project where the delivery time grows exponentially. Particularly after 1 million lines of code, it's terrible, because it's not only the number of people and communication, it's also the fact that the longer it takes, more ideas come from the customer, from the people on the team and so on. So change becomes like a day by day. So it sort of ball rolls.
And this is forming the basis for agile software development.
And that is forming the base for agile. The agile, we get into complex systems